Okay, so we have a bias coin this time and it's tossed 3 times again. And the probability of obtaining a head on this coin is P. Alright, so find in terms of P the probability of obtaining 3 heads. So we have 3 trials, probability of success is P, X is equal to 3. So I've got 3C0, P to the power of 3, 1 minus P to the 0, and that just simplifies to P cubed. Alright. If I'm going to use the same coin and this time I want to get the probability of obtaining 2 heads and a tail, so again, I want probability of X equaling 2, so I've got 3C2, gives me the combinations. 2 heads is P squared, and times 1 minus P to the 1. So 3C2 is 3, so I get 3P squared times 1 minus P. Alright, so there's my 2 probabilities. For the part B, it says if those 2 probabilities are equal to each other, find P. Alright, so in other words, if P cubed is equal to 3P squared times 1 minus P, expand the group terms together, we'll end up with a 4P cubed minus 3P squared is equal to 0. Take your P squared out the front, we get 4P minus 3 equal to 0. So we'll have P squared is equal to 0 or 4P minus 3 equal to 0. That gives me P equal to 0 or P equal to 3/4. Now there's nothing to say that P has to be greater than 0. Maybe the coin is that biased that it's a double, what have we got? We can't get a head on the coin, it's a double-sided coin. Okay, and so if the probability of obtaining a head is 0, that condition will be satisfied still. So P equal to 0 is a valid solution, P equal to 3/4 is the other one. All right. Finally, if we roll a second fair dice, so this one's fair, a second fair dice, it should be a coin. So obviously we're talking about a coin there. It's also been rolled 3 times. What is the probability of obtaining 2 heads given that at least 1 head occurred? So probability that X is equal to 2 given that X is greater than or equal to 1. So there's my conditional rule. The intersection of equaling 2 and being greater than or equal to 1, X equal to 2 is the only one that satisfies both conditions, divided by the probability that X is greater than or equal to 1, which is the same as 1 minus the probability that X is equal to 0. So if we use our distribution, probability that X is equal to 2, 3C2 a half squared times a half to the 1 over 1 minus 3C0 a half to the 0 a half cubed. So we end up with 3 times 1/8 on the top over 1 minus 1/8, so 3/8 on 7/8, which is equal to 3/7. If you were to think this one through, if you remember you're tossing a coin 3 times, so we either have 0, 1, 2 or 3 successes. Probability of 0 successes is 3 tails, if you like, which is a half by a half by a half, so that's 1/8. The probability of 3 heads is a half by a half by a half, so that's 1/8. And that leaves these as both 3/8 from symmetry. All right, so just from using a bit of common sense, I guess, what's the probability of obtaining 2 heads given that at least 1 head occurred? So if 1 head occurred, it means that's not an option. Change the colour. Yeah, so that's not an option. So there's 3 ways that I can get 2 heads, and there's a total of 7 different options. So there's my 3 out of 7. All right, so you could get there intuitively as well.